Hello, my friends. I am Shivam Yadav, and I am going to talk about an abstruse scientific concept known as the Higgs boson particle. Now, many of you might wonder what is Higgs boson particle, but you may be knowing it by its another non-technical name that is known as the God particle. Now, in order to understand the concept behind God particle and why is it related and what it is related to, which is of course dark matter and dark universe, we need to understand the contemporary state and the mechanism that lies behind it. That is the Brout-Englert-Higgs mechanism. Now, the early 1970s, physicists realized that there are very close ties between two of the four fundamental forces, that is, the weak force and the electromagnetic force. The two forces can be described within the same theory that forms the basis of the standard model of the universe. This unification implies that electricity, magnetism, light, and some types of radioactivity are all manifestations of a single underlying force known as the electroweak force. Now, this all being closely related to the dark matter. Now, in order to understand the dark matter, you need to understand the birth of our universe. Now, many of you might know it, so let's bring it up to speed. Around 30.7 billion years ago, there was a great explosion in the void, which is, of course, perceived by many scientific communities to be as. And it released an unfathomable amount of energy, gases, of contained mass, which were initially only in the form of hydrogen, and through its gamut of spontaneity, it changed forms and became into another gases as we know it, changed shapes and became the universe as we know today. But as we know that our scientific community has not been able to perceivably consider all the ideas that surround the studies related to our cosmos. And why is that? Because around 3%, only 3% of entire universe is what you may call it, the normal mass or the matter as we call it. Because there is a distance to the observable universe that is around 10 to the power 24 meters. I don't know, you have to check that. But what lies after that? Do you think that is the end of our universe? No, that is the end of our local supercluster known as the Laniakea. This is our Earth. It lies in our solar system. Solar system lies in our galaxy known as Milky Way, which is one of the many galaxies. The other being Triangulate, uh, Andromeda, and many other. It lies around in our local cluster, and our local cluster lies in the supercluster known as Laniakea, and that is the local supercluster which holds everything, every galaxy, and every matter of energy that we know of today, as per scientists. But what scientists tell that after that, after our Laniakea supercluster, there is just dark, dark, dark energy. What they call it. Then this is the question. Is that the end of our universe? Have we reached it? No. That is so not the end of our universe. It is considered of our enormously, enormously humongous universe. Our Laniakea supercluster might just be a small part. And after that, there lies a big leap of darkness, and then comes the another matter of the universe. This is what our predication is based upon. But now you may call it, why is that? Then there is only one perceivable answer, and that is scientists say that the light has not been able to reach our supercluster from that distance leap. That distance has not been covered by the light in 13.7 billion years ago. That how far the another part of the universe is. And you may call it, why is it so? Light is the fastest. Of course, the fastest there is. But you may think That light has been not able to reach our galaxy because entire universe has been contained what is called as the dark matter, the dark energy. Around 96% or the more of it is dark matter and dark energy. And it is perceivably considered that it might be made up of an elementary hypothetical particle known as Higgs boson, in layman terms, the God particle. And also, this is the very particle which would explain the existence of every other subatomic particle that make up our quantum physics, contemporary physics, and every other aspects of scientific studies that we know of today. Thank you.